Dear students, welcome back. In this section, we will discuss about the compound manometer. The manometer is called as compound manometer because if I am going to see this section, it is a normal manometer. If I am going to see this section, it is a inverted U-tube manometer. If I am going to see this section, it is a normal U-tube manometer. So it is somewhat compound. It's not simple. It is an addition of normal manometer and inverted U-tube manometers, and hence the name is called as compound manometer. This device is also used to find the differential pressure, that is the pressure between the fluids A and B. Okay, A and B may be of any liquid. In this example, we have taken both A and B as water, which has been given in the blue color mark as water. Whereas this red color line, I know or we know that whenever we want to have a normal U-tube manometer, it should be of higher density. Here the higher density fluid is mercury, whose specific gravity is 13.6, corresponding to a density of 13,600 kilogram per meter cube. So the density of this mercury here and here, both are mercury. This is also mercury, this is also mercury. So whenever it's a normal manometer, we will have higher density fluid, namely the mercury, whose density is 13,600 kilogram per meter cube. Whereas when I am going for a inverted U-tube manometer, in this diagram, this portion is nothing but what? Inverted U-tube manometer. So I should have an oil or any fluid whose density should be lighter than water. Should be lighter than water in this case, or lighter than the two fluids whose pressure is to be determined. So here the specific gravity of this oil is nothing but 0.85, which means its density will be equal to what? 850 kilogram per meter cube. Now they are given the height of this water column from A up to the mercury level is 1.08 meter. Similarly, in the right hand side limb, the mercury has risen to a height of 0.27 meter from the datum height. Similarly, here the oil has come down to a height of 0.48 meter from the datum position. Similar to the other side, the mercury has risen to a height of 0.6 meter. And the distance from the center of the B to this particular height is 0.96 meter. So these are the data which is already given in the problem. So my question will be now, what may the question they can ask? They can ask either find PA minus PB or PB minus PA, because this compound manometer is also used to determine the differential pressure between A and B. If P minus PB is positive, means PA is greater than PB. If PB minus PA is positive, means PB is having higher pressure than PA. So the only question from this diagram they can ask is find the differential between A and B, differential pressure between A and B, that is PA minus PB or PB minus PA. Don't worry about the sign. Now, how to approach this problem very easily? How to solve within some 5 minutes? How to solve this problem? I will tell you. I will make use of the top portion of the board so that we can make use of the diagram also. I will start with the left hand side. What are the left hand side? Here, when I am going to consider from here to here, this is my session. This is my session here. So this is my session. So it has to be XX. So let the points be C and D. So what do we know? Pressure C equal to pressure D. Got the logic what I am telling? Pressure C should be equal to pressure D. Then once again, I can draw another line. I can draw another datum line because it's an inverted U-tube manometer. The datum line should be at the topmost possible. So this is the line. Got it? This is the line. So up to this side is 0.48. Okay. When I'm coming to normal U-tube manometer, it should be at the maximum down possible. So I have drawn the plane at XX and the name as CD. Now let us call this name as the what? YY. And we will call the point as what? E and F. Now it becomes a normal U-tube manometer. So our data should be at the maximum down possible. So I will draw it like this. So what is called as? Let us call as ZZ. And let us name it as what? C, D, E, F, G, H. I will repeat what are the steps we have done after given the problem. We have made 3 datum lines. There are 2 normal YouTube manometers and 1 inverted YouTube manometer. In the normal YouTube manometer, we have to find the datum height at the maximum downwards possible. So here the maximum downward possible is nothing but the separation of the liquid A and the mercury. So from C, I am drawing a horizontal line. This is nothing but my first plane. Then coming to inverted YouTube manometer, it should be at the topmost possible. So here I should not stop here. I had to go up to this point because this is the point where it is separating between the mercury and the oil. So this is nothing but what? YY. And we'll call the points as E and F. And once again, it's nothing but what? Normal YouTube manometer, where I'm going to draw a maximum downwards possible. So the downwards is nothing but what? Z, where the oil and mercury get separated. Let it be G and H. And other things are remain same. Now I hope you are clear how to choose the 3 datum heights. Now we'll ask you a question. What are the pressure at C and D? Yes, you are right. Pressure C and D are same. What are the pressure at E and F? They will also be same because they are in the same datum height. Very good. What are the pressure at G and H? Amazing. They will also be same because they are the same datum height. By this approach, we are trying to move. By this approach only we are trying to move. The approach is very simple. The pressure at C and D will be equal. The pressure at E and F will be equal. The pressure at G and H will be equal. Based on this principle, we are going to solve this problem. Okay. How to solve it? Let us start from the left hand side. So PA. Weather plus rho A into G into HA. Whether it is positive G or negative G, it is positive because the water is coming downwards. G is positive. Otherwise, I'll tell you like this. Whenever it's coming down, positive. Whenever the liquid is going up, it is what? Negative. So this is what? Positive. This is what? Negative. This is what? Positive. This is what? Negative. I will repeat the step. Whenever the fluid is coming downwards from top to bottom, it is positive. G is positive because towards the gravity. On the other side, when it's going up, it is negative. When it's coming down, it is positive. So once you take a cycle, you move from the left to right. Okay, don't change the order. So it is positive. Another is what? Negative. So this is the approach we are going to go. So I came from PA plus rho A G into HA plus rho A into what? This is the density of A. G is positive and HA. HA is nothing but what? It's not 0.72. It is from A to this point. This point is what? 1.08. HA is equal to what? HA will be equal to 1.08 because we are moving up to C. So the distance will be from the center of this A to this datum height will be 1.8. So HA equal to 1.08 meters. Then we know that the pressure at C and D are same. So don't worry about this section, leave it. So from C, I am jumping to D. From C, I am jumping to D. So here what you do means you put as minus sign. Why are you putting minus sign? Because I told the fluid is moving upwards. So when it's coming down it's positive, when it's going upward is negative. So minus, what is this one? Mercury. Red color is mercury. So it's rho of mercury into G. Because of G only, it become negative. Into what is the height from this D to Y? It is 0.72. Into what? Is already given the problem. 0.72. Now you tell me whether this will be the pressure at E and F are same. So it's enough to jump from E to F. So there's no need to find what is the pressure in this column. Okay, YouTube. So you jump from E to F. Now from F to this point, whether it's positive or negative, is positive. Because already we have written this is positive. As far as fluid is coming downwards. Now it's not the density of mercury, it is the density of the oil plus density of the oil into gravity. Gravity, you know, because of this positive into the height. Height is what? 0.48 with respect to this datum. So it is 0.48. And once again the mercury is going up. So it's negative. So minus. I am writing about this one. Minus rho into Hg into G. Because the gravity is against, the flow is against. So because of G only it become negative. Into its the height. What is the height? Its height is 0.6. Its height equal to 0.6. Then what about this height? I want this height. Which height? I want this particular height. Let it be say such. This height will be equal to what? 0.96 minus 0.6 will give me the height between the center. I hope it is clear. If I'm going to have this height minus this height, this will give my this side, because that is height I want the pressure which is exerted by the liquid B because of the vertical height H. Okay, that height will be what? Whether that will be positive or negative. Once again, the question will be there. Whether that value will be positive or negative. With respect to this one, it will be negative. So it will be my value is going like this is negative minus rho of water. Rho of water means rho of B here into G. Why it's negative? Because of this water is moving. It is still this water is above this one. So it's negative into what is here it is 0.96 minus 0.3. Sorry, 0.6. This 0.96 minus 0.6 will give me 0.36. That only we have written here, which will be equal to PB. Which will be equal to PB. I will repeat the steps once again. I am starting from left hand side and I am going to reach the right hand side. So it is PA plus this rho GH. That rho GH is positive because coming down. I am moving from C to D because both are the same pressure, but the mercury is moving up, so negative minus rho GH only, rho of mercury into G of mercury into this side is 0.72. E and F are the same height, so I am jumping from E to F. Once again, this oil is coming down, so it's positive. So rho of plus rho of I into G into this height is 0.48. Now the mercury is going up, so it's negative. So minus rho of mercury into G into 0.6. Okay. Then once again you should not forget about the small height, because this height will be also the pressure exerted by the liquid B. So that is also negative. Why? Because moving up with respect to this datum. So it is minus rho B into G. Rho B means the density of the water of the B into G into what is this height? It is 0.96 minus 0.6, which is like but 0.36, which will be equal to PB. So from this equation, what are the unknowns? You know rho A. What is rho A? Rho A equal to 1000 kilogram per meter cube. What about G? 9.81. What about HA? HA equal to 1.08. Already we have written here. Already we have explained also. Then rho of mercury also we know. Rho of mercury equal to 13,600 kilogram per meter cube. G is also known. This height is also known. Rho of the oil, already we know it's what? Rho of oil will be equal to 850. Why? Because the specific gravity is 0.85. Its density should be lighter than water. Yes, it's lighter than water. It's less than 1000. So it's 850 is right. So rho of 1000 into, 850 into 9.81 into 0.48. Then I am coming here, density of mercury 13,600 into 9.81 into 0.6. Okay. Minus density of water is what? This B is also water here. So it's minus 1000. Rho B is also, I can write rho A equal to, rho B is also equal to water. So 1000 into 9.81 into 0.36. So this entire equation has all the values except PA. Some values will be equal to PB. PA minus some value will be equal to, let us say that value is X. PA minus X equal to PB. So PA minus PB, we can find out what? PA minus PB equal to what? X. Now this value of X, I hope if you are going to solve, it will be 165.8 kilonewton per meter squared. I am not doing the full calculation, but I hope you can do on your own and you can find the value of PA minus PB. What does it indicate? The pressure of A is more than the pressure of B by 165.8 kilonewton per meter squared. That is the final thing we are arriving at. Here I may make a small mistakes in the numbers, but don't worry about the numbers because I am not taking the accurate decimals. If you are going to take the accurate decimals, you will end up with the answer. So I hope it is very clear. Okay, and please enjoy the subject of the compound manometer, which takes care of both the normal U-tube manometer as well as the inverted U-tube manometer. Once again, the logic is to find the differential pressure between two liquids. These two liquids may be of the same liquid in nature or may be of different liquid in nature. That's the only approach. I hope you enjoyed it. Thank you.